Rain strikes the nesting ground before the egg breaks. Mud trembles under a thin sheet of running water. Broken leaves slide between rounded eggs half. Buried in the nest, one egg rocks once. Then again, not peacefully, not gently, but under pressure from inside and from the storm outside. A crack opens along the shell. Water runs toward it. A tiny foot pushes through, wet with mud, and slips before the hatchling has even seen the floodplain. Birth is not the safe part. Birth is the beginning of danger. Baby dinosaur leaving the egg entered a world built for larger mouths, heavier feet, changing weather, unstable ground, and hunger. The shell had protected it from the outside for a while, but the moment that shell opened, the problems changed. Now it had to breathe, move, avoid exposure, find food or receive care, and survive long enough for growth to matter. That is why baby dinosaurs are not just cute versions of adults. They are evidence of a dangerous life stage. Dinosaur eggs, nests, embryos, and nesting grounds are among the rare fossil clues that show us reproduction and early survival. They do not tell one simple story for every dinosaur. Some species may have cared for young. Some may have left hatchlings more independent. Some nested in colonies, some buried eggs, some may have guarded nesting areas. The evidence varies, and the behavior must be reconstructed carefully. But the first rule is clear. The nest was not separate from the ecosystem. Look back at the cracked egg. The hatchling pushes again, the shell widens, and rainwater slides into the broken opening. The tiny body inside is not built for a heroic escape. It struggles, braces, kicks, and rotates. The nest material shifts beneath it. Wet mud can support a shell, but it can also trap a foot. Water can cool the egg, flood the nest, or wash away protective cover. A storm could turn a nesting ground into a test. If the nest sat on a floodplain, even a shallow flow of water could matter. Eggs need the right conditions to develop. Too dry, too wet, too exposed, too buried, and survival changes. A hatchling that emerges during rain may face mud before it faces a predator. It may slip before it walks. Its first movement may be a scramble away from water running into the nest. That first step leaves a fossil idea behind. Tiny tracks in mud, eggshell fragments, clustered nests, and embryos all help us imagine these moments. But none of them lets us pretend every hatchling behaved the same way. A duck-billed dinosaur nesting colony, a small theropod nest, and a sauropod egg field would not all have the same survival strategy. Baby dinosaur is not one animal. It is a category filled with different bodies and different risks. Now the shell breaks wider. The hatchling's head lifts into rain. Its eyes blink against mud and water. Its body is small enough to be hidden by the rim of the nest. But smallness is not only protection. Small animals lose heat faster. They dry out or chill more easily. They are easier for small predators to carry away. They can be crushed, stranded, or separated. Huge adult dinosaur might fear only a few enemies. A hatchling could fear almost everything. At the edge of the nesting ground, something small moves between low plants. Not a giant predator. Not the dramatic hunter people expect. A smaller scavenger or predator may be a more immediate danger to eggs and hatchlings. Teeth do not need to be enormous to break a shell or seize a newly emerged animal. The first predators around a nest may have been quick, low, and opportunistic. The hatchling freezes. Rain taps on the broken shell. The small predator darts closer, then stops. Far in the background, an adult silhouette shifts through the gray light. That silhouette may mean protection in some species, but it cannot be treated as a universal rule. Fossils suggest parental care in some dinosaur groups is possible or likely, while other young may have been more independent soon after hatching. The question is not whether all dinosaur parents cared. The question is which dinosaurs, how much, and what evidence supports it. A nest can preserve arrangement. It cannot preserve every decision. Some dinosaurs laid eggs in organized nests. Some nesting sites suggest repeated use of nesting grounds or colonial nesting behavior. A colony might reduce the risk for any one nest by surrounding it with many eyes, many adults, or simply too many eggs for predators to consume all at once. But a colony also creates smell, noise, and movement. It attracts attention. Safety and danger can come from the same strategy. The hatchling finally pulls free. Its feet slide in the mud, leaving two small marks beside the broken shell. The body is wet, awkward, and low. It does not move like a perfect miniature adult. Young animals often have different proportions, different needs, and different behavior. A hatchling's survival depends not only on anatomy, but on timing. Can it stand soon enough? Can it leave danger? Can it find food? Can it stay near adults if care exists? Can it grow before predators find it? Growth is a race. For many young dinosaurs, the earliest stage may have been the most dangerous, because size changes everything. A small body fits into more hiding places, but it also fits into more mouths. As the animal grows, some predators become less dangerous, but food demands increase. Surviving the first days, weeks, or months could decide whether the hatchling ever reached the body size that made adult survival possible. Rainwater begins cutting a channel through the nest. No egg remains unbroken. Another has already collapsed. Eggshell fragments float at the edge of the depression. The hatchling steps away from the broken shell, then stops as water crosses its path. A few inches can become a barrier when the animal is only a few inches tall. The same landscape that an adult crosses without noticing can become a maze for the young. This is the scale shift that matters. A footprint of an adult may become a puddle. A root may become a wall. A shallow stream may become a flood. A nest that looked safe when dry may become dangerous when rain turns the ground into flowing mud. Survival after hatching was not only about escaping predators, it was about moving through a world at the wrong scale. Another hatchling breaks through nearby. Now the nesting ground has more movement. Tiny calls, slipping feet, rocking shells, and running water create a chaotic surface. If adults were present, they may have defended the area, shaded nests, or guided young in some species. If adults were absent, the young may have relied on camouflage, rapid movement, group emergence, or simply the odds of many eggs producing enough survivors. Different dinosaur lineages likely solve the problem differently. That uncertainty is not a weakness. It is the science. Fossils are physical remains, not complete biographies. Eggshells can show structure, embryos can show development, nests can show placement, trackways can show movement, bone growth can suggest how quickly young changed. But behavior must be built from clues and compared cautiously, not declared as one universal parenting story. The small predator darts again. This time the hatchling moves, not fast, but suddenly enough to slip behind a broken cluster of eggshells. The predator pauses at the edge of the mud channel. In the distance, the adult silhouette turns. Maybe it is noticed, maybe it is not. The scene remains unresolved because many real hatchling lives would have been unresolved. Some survived because of care, some survived because of numbers, some survived because they hid. Some did not survive at all. The storm weakens, the nesting ground is changed. Shells are broken. Water has cut lines through the mud. Small tracks lead away from several nests. Some tracks end at puddles. Some disappear under washed sediment. Some continue toward low vegetation at the edge of the floodplain. Those tracks are the heart of the story. The egg is dramatic, but the path after the egg is the real survival problem. Baby dinosaur had to leave one kind of protection and enter another. The shell was gone. The nest was temporary. The adult, if present, could not erase every danger. The colony, if present, could not save every individual. Growth might eventually transform vulnerability into strength, but growth required time, food, and luck. So the most dangerous moment was not simply the crack in the shell. It was the first journey away from it. The final hatchling stands at the rim of the nest. Rain drips from the broken egg behind it. The mud holds the shape of its feet for a few seconds before water softens the edges. Ahead, vegetation bends under the last drops of the storm. The hatchling moves into it, one uncertain step at a time. The camera stays on the mud. Tiny footprints leave the broken nest, cross the wet ground, and disappear into dark green cover. We do not know whether this individual survives, but we know what the first challenge looked like. The shell broke. The world began.